We all want production-ready designs, right? I don't think I've ever run into an engineer that said, yeah, you know what? I'd like my design to be slow to market, be obsolete in 18 months, and be an overall risky endeavor. Yes, that sounds absolutely ridiculous. So, we all want to reduce our risks, speed up our time to market, and have our designs be future-proof. But in order to do that, we need platform versatility. We need a robust ecosystem that includes hardware and software. And we need our designs to be able to successfully steer through the complex regulatory landscape of today's embedded designs. But how do we go about actually doing that? By starting with this here Chalk Talk. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Kyle Fox from NXP, Mohamed Raad from Toradex, and I discuss why proven, pin-compatible product families and industrial IoT platforms are essential for scaling and long-term maintenance. We also discuss how NXP's i.MX family and software platforms enable advanced physical AI capabilities, explore the biggest benefits of Toradex SoMs, and investigate how you can navigate the regulatory landscape using NXP's EdgeLock and Toradex's Torizon industrial-grade software platforms. And before we get started, don't forget to click that link. There you can find even more information about this topic. Hi, Kyle. Thank you so much for joining me.
Oh, my pleasure.
And thank you for joining me, Mohamed.
It's a pleasure. Thank you, Amelia.
Absolutely. Okay, so Mohamed, we're talking about production-ready embedded computing today. But before we dig into the details, tell us a bit about Toradex.
Yes, Amelia, thank you for having us today. I'm quite excited to talk about Toradex and production-ready volume products in the end based on embedded computers. So Toradex, we make embedded computers. It's basically computers for people who have harsh environments, who need high reliability in the field. You can see that in multiple applications. We don't only do hardware, we have also a very big software offering from BSP to a managed operating system with Torizon OS, and then we also help you with cloud services, especially now getting much more attention with CRA coming up very soon. From our perspective, we're really a provider of turnkey solutions for embedded computers, whether it's hardware, software, or the whole complete solution for customers.
So, Mohamed, what kind of applications and industries are we talking about here?
You need to think about it in every application that is not a laptop and not a smartphone. So we tend to the industrial space in general. You can think about manufacturing automation, small robots or bigger robots. We tend to the medical sector from, MRI machines to lab equipment as well. We do some automotive, we call that special vehicles. So it's basically all of these autonomous agricultural vehicles. We've had race cars as well, things like that. We recently also worked a lot with energy, whether it's renewables or energy management in the house, in homes. And then we also have flying objects that I like to call that, whether it's drones or other types of aeronautical objects that go around. Very cool applications. And we really like our customer base because we get a lot of variety, and we get a lot of variety in terms of use cases, in terms of environments that we need to tend to, and volume. So you get very cool projects that only need hundreds of pieces a year. And then we have very cool projects as well that need thousands of pieces or hundreds of thousands of pieces. And we're really happy that we're able to tend to all of these sectors in the market. It's super cool.
So, Kyle, let's talk about i.MX. What kind of benefits does this solution in particular provide when it comes to physical AI?
Physical AI has a lot of different components to it. And Mohammed was going through all of those different industry segments, market segments that Toradex is focused on. And one thing that should jump out is that each and every one of them are going to have a set of things that are similar and many, many things that are very, very different in terms of what they care about, where they're going, what physical AI means to them. And realistically, everything in the previous slide has some aspect of physical AI, which is what i.MX is all about. So if you really look at what a set of systems are going to need, we have a cognitive layer. So you need to have something that can orchestrate and make decisions. There are needs for perception. So if you've got a robot moving around on a warehouse floor, or you've got a lawnmower or an automated tractor, and I like what he said, objects that fly, they need to perceive the real world. And there's multiple ways to perceive the real world. You can use cameras, thermal cams, LiDAR, radar, the whole 9 yards. And then you actually, almost like a human body, need to have a nervous system. You need to have the ability to take the data that you've got either from a vision system or from a cognitive layer and get that out not only within the solution itself, in my world, the chip, the i.MX processor, but also to other i.MXs or other solutions that are within the overall network. A drone needs to communicate with a base station or an end user. A PLC machine that's manufacturing something needs to be able to talk to other systems that tell it what its workload's going to be. And then the final one is one of the coolest parts of this is user interaction. And this isn't just touchscreen. When we think about the world of AI assistance, this user interaction is very, very broad. So being able to walk up to a medical machine and speak Italian when you're actually in a German speaking hospital, and the machine itself has an AI inside of it, and it's able to translate instantly. It detects that you're speaking Italian and speaks back to you in Italian. You can take that exact idea into the homes. So voice, our ability to communicate with our devices, no matter what they are, and actually get a measured response that's AI driven is all a big part of this. And so i.MX and NXP in general, we have a lot of different solutions that push into physical AI, but our focus is to be an enabler and a technology driver for physical AI. So our i.MX processors encompass each of these 4 layers that we're looking at. In some cases, all in one chip, and in other cases, there's specialty chips that work on one particular area. And really, when you think about physical AI, it's about scalability. So it's one thing to have processors, but you need to be able to have leadership, and NXP gives you this for scaling those solutions. So different performance levels are required, whether you have objects flying in the air or something moving around on the ground. Enablement is critical. So working with companies like Toradex and with our own software enablement and solutions enablement that we provide out to the industry allows people to build these solutions. And what we'll be talking a lot about in this presentation is around safety and security and how you're able to harden these systems, because hackers attack the weak link. And that's something we all have to care about and proactively do something about.
Yeah, so Kyle, walk me through the different elements of this ecosystem. What kind of software, IP, and platforms does NXP offer for these kinds of applications?
Well, it's great. And it's actually somewhat simplistic in how we approach this. We obviously spend a lot of our time on our scalable hardware platforms. So we have a full range of MCUs, our LPC, Kinetis, and MCX processors, to our i.MX RT, which we call crossover MCUs. They fill in that boundary between an MCU and an apps processor. And then, of course, i.MX with the apps processors. And this is just looking at this through my world within NXP i.MX. We also sell and build and sell processors directly into automotive. We have radar solutions. We have Wi-Fi solutions. There's a whole gamut of analog, power management, sensors, connectivity that underlie each of these processors. Now, the way we are able to help with that complexity and understand what software we need to put out there to help with that is differentiated IP. So the structure within NXP, we literally have tech centers whose sole job, and you see some of the lists here, AI, ML, and vision, power conversion, motor control, touch, graphics, list goes on. These are teams that are dedicated. That's what their day job is to go in and look at the full range of what's happening in the industry and what we need to commit to silicon and what we need to commit to the ecosystem to actually enable this. So AI/ML is a great example everybody's familiar with. If you just put a hardware unit out there and say, have fun, you're really not going to get much traction, right? There's just a whole wealth of tools and software that have to be on top of that, which brings up the last point. I listed here as application software, but this is everything from BSPs to board support packages for Linux, for Android, for QNX, for Green Hills. The list goes on, but also tools, reference designs. For instance, our EIQ toolset is designed to enable somebody to bring their own AI model to i.MX or the RTs or even the MCUs and optimize it for each of those processor systems. So it's a vital tool that enables you to say, here's my performance and here's how you unlock it, how you use it for yourself. So all of this comes together in for the customer to say, I get to pick a processor. It's going to with this type of differentiation, and here's my tool set to make it enabled, which really sets the stage for our key partners like Toradex, because they absolutely take what we do and bring it 3 levels beyond.
You make the job easy for us, Kyle. I mean, it's the enablement we get.
Well, you're selling yourself short. They Toradex it does some amazing work. I have a couple Toradex boxes on my desk as well. But I think the key point between this is that it does take a village, right? It's a continuum, and every customer is slightly different. Some of them absolutely are just, we can totally do this on our own. Others need help in certain sections and they do the rest. And some really are in a turnkey business. They're like, I need to make this stuff work because my value add is beyond the actual guts of the machines that we're doing. I'm doing something else and I just need this to work.
So, Kyle, pin-to-pin compatibility is a crucial design concern to keep in mind, right?
Yeah. So what does pin compatibility mean? It actually is a number of different things, because what are we trying to achieve? What's the problem? Well, with i.MX 9, what we want to be able to do is sit across the table from a customer and say, you can start here and you can be wrong. And I know that sounds a little weird to say it that way, but what I'm saying is, if I can give that customer a processor like the i.MX 9.5, and they find out a year and a half later that they've kind of missed the mark on what performance they need, and they actually need a lower end device, that's what I mean by wrong. They go, oh, this, market conditions have changed, and now I need a device that is lower performance. So it comes down a little bit because I need to be able to bolster my roadmap with a lower end device. And that's what really it's all about, is it allows the product definers and the folks that are putting these products out the flexibility to change as their market changes. They don't get completely locked into one solution, they're done. And pin compatibility gives you that reuse. So you quite literally, with our processors, you can design one board with one PMIC solution and pop the processors. And that's what we're heading toward. And we've done that with the 6 series. We've done that with the 8M series. And with the 9 series, we've already started that with the 9.3 and the 9.1, both of which are up on Mauser's Day. And what the message here is, you can start with i.MX 9.5. So absolutely, this is a great starting point. It's up on Mauser right now. And these little coming soon boxes. So my team is busy putting out processors that are 100% pin and power compatible with the 9.5. So a Mauser customer, a Toradex customer, an NXP customer that wants to do something maybe a little lower than the 9.5, you don't have to wait. Build with the 9.5 right now. In a year and a half, you'll have another processor that actually hits the target level of performance you want. And once we have these other coming soons in place, that's when the real magic happens. You could start at the low end and migrate up, or you could start at the high end and migrate down, or you can start right in the middle and go left and right. There's really a lot of choice, and that's what pin compatibility is. It gives the customer choice.
That makes sense. So, Mohamed, let's talk about the various elements that we should keep in mind when it comes to production-ready embedded computing.
I'd like to add to what Kyle was saying before, because it really makes a lot of sense and comes back to exactly what we're going to discuss here as well. This whole pin compatibility that we also prone at Toradex with our modules, to me, it creates a condition where the iteration cost and the opportunity cost of working with a certain processor goes way down. You can start, as Kyle was saying, with a beefed up processor and then figure out, oh, maybe my market conditions changed. I need to move to something else. The barrier to change has significantly been reduced. And that is helping our customers as well today. But what Kyle just said, i.MX 95. Yes, we have customers working on that with future plans to go lower performance because of changing market conditions that we've been seeing in the past year or two. That is definitely happening, and it is definitely being enabled by the mix of what we and NXP do to reduce the iteration cost. in our products and in the products we offer to customers. So to answer your question, Amelia, and going back to the subject, a lot of discussions that we have tend to revolve always around bill of material, memory costs, oh, how much does this cost, how much does that cost, etc. And it is, of course, a major part of how you go to volume because you need to prove your business model and have a scalable plan going forward and growing as a customer and as a company. But it's not the full picture. It's just the tip of the iceberg, especially with embedded computers. Embedded computers come with a lot of compliance. They come with development costs that can be quite significant if you do not have experience building that before. They come with operational costs, and we've just talked about the whole memory situations. This is people that need to go in and periodically renegotiate prices, fight for supply, etc. This is cost. This is people that are not doing something else. There's maintenance, and we're going to get to that probably later today, talking about maintenance in terms of software. How do you maintain that software? How do you maintain all of that? And all that work that you're putting in as a development company to try and build an embedded computer, that is all work to me, that is opportunity cost. Resources you could have been spending somewhere else in your own core business to have a lot of more leverage to compete there. So that's what we try also to educate and to look at with NXP and with Toradex, is to look at it from choosing a module for an embedded computer is actually a better longer term choice than trying to do the chip down yourself and try to do the whole thing. It's not because you can't do it. Of course you can do it. It's because the hidden costs that will accumulate with time may actually bog you down from creating much more innovative solutions that Kyle was mentioning before around a real-time translation from Italian to German in an operating room. That is not our core business at Toradex. It is what we try to enable customers to do with the time and costs that we save them that are not reflected directly on a bill of materials. That's a bigger picture I'd like to expose with us today.
What do you think are the biggest benefits of Toradex SoMs, and what sets them apart from other solutions on the market today?
I can tell you, Amelia, and that doesn't come from me personally. That's exactly what I hear. What sets us apart is quality and reliability. And what sets us apart as Toradex is software. Our software lineup is something we are very proud of, and we work tirelessly every day to keep improving on it. In a nutshell, three things for Toradex SOM. You have really high quality, really high reliability. We help people achieve revenue in as little as 6 months to a year. And then we've really calculated what our customers can gain on a total cost of ownership level. They can really save half of what they would spend on lifetime cost because of the software we provide, that we test every day and that we improve on every day. All of that doesn't go into a bomb. All of that goes afterwards, in the future of your company, in the future of a customer's journey in volume production.
Walk me through a typical design roadmap from evaluation to production.
I'll try to compare for you how a typical chip down design would go. We go talk with NXP, and you might see Kyle at Embedded World running around, and you catch him and say, "Hey, Kyle, I need i.MX 93." Yeah, let's talk to marketing, let's talk to some procurement guys, etc. By the time you get those samples and you make your first proof of concept after laying out PMIC, the RAM, the eMMC, all your high-speed signals, and figuring out what you want to do with interfaces, etc., it will take you probably, I would say, a couple of years until you get to a rugged working prototype. Then you get into probably in the middle of year 2 to year 3, that's when you go to industrialization. And that's where you're going to have to work with suppliers, getting your PCBs ready. These are not simple PCBs to manufacture. It's not easy to order them online. You have memories. I mean, today, good luck, even good luck for us to try and find LPDDR4 and LPDDR5 memories on the market. You're going to get hit with a lot of pricing challenges, etc. Probably would take around 3 years to start making real revenue on your product. That is if you're trying to go, solo on this and you don't want to use a module and trying to save a significant amount as well. And we can't lie to people. We're trying to save some BOM cost. But what has just happened is you've practically lost, I would say, around 2 years of revenue by going that road. Today, as Kyle mentioned, there are some i.MX 93 modules from us or from competitors, right? But from Toradex that are out there in the market. We have i.MX 8M Plus that is available. You take that module. We have a lot of data and design resources that will help you get your prototype out in probably less than half a year. Then you take the other half of the year to work with your production line, how you assemble the module onto the carrier board and in the final product, some certifications as well. And I think if you can go really quickly as a customer to market, you're generating revenue within a year or two, rather than taking around 3 years to generate revenue if it's your first time doing a chip down with i.MX processors. And it took us 20 years to get here. So it's not about that we have something special. It takes time to build up that know-how. Some people don't believe it, but they usually come back.
So, Kyle, speaking of roadmaps, what does the i.MX Linux roadmap look like?
It's an interesting snapshot into exactly what Mohamed was talking about. So part of the reason why I put this slide up is because it kind of looks daunting. There's a lot of choices there at the bottom of processors. There's a whole bunch of boards there in the middle. And then there's some flavors of, by the time you get to the top of the slide, unless you really, really understand what you're doing, it's kind of like, which one do I pick? And really, there is some simplicity here to say, okay, you're going to have this processor, that configuration of Linux, et cetera. Well, we do this for Linux. We do it for Android. We do it for FreeRTOS. We're working on Zephyr. We work directly with QNX. We work directly with Green Hills. Those two companies produce their own operating systems and roadmaps based on our technology. You can start getting a sense for how broad this is and how much effort needs to be done just to get one BSP set up. And so we try to make it easy. For instance, when we release a Linux, and I'm very focused on Linux Yocto here. We can certainly have a conversation about Android and the rest, but Linux, when we put a release out, you'll look at the release notes and you'll see like 25 i.MX processors in there or combinations thereof that this BSP works on. So when we pop one of these boxes, it's pulling together a whole bunch of stuff, validation, testing across a lot of different processors. And that's just our step, right? We also have different applications, EIQ, that sort of thing. But this is what we give to our partners, Toradex, as an example here. And then they are able to take it the next step. So they have their own Torizon OS. They have this wonderful tool chain for being able to do Dockerized Docker containers to be able to deploy code and be able to manage their systems remotely, fleet management, individual management, the whole 9 yards. So the complexity you see on this slide, we give that to Toradex, and I don't want to steal their thunder. They've got a couple slides here that then take it into a full solution. So when you get that Toradex board with an NXP piece of silicon on it, you're looking at a very, very deep bench of software support that starts with us and goes all the way up through Toradex. I should just mention that the other thing that doesn't just jump out of here is that we are very focused on LTS. So when we pop a kernel revision, we are locking ourselves to the long-term support kernel. And because NXP's business is about longevity, we routinely sell for 15 years. I actually have processors that have been sold and continue to be sold at much longer than 15 years. So the next iteration of a phone, in 6 months isn't really what we're trying to get ready for. We're trying to get ready for customers that 9 years from now need to do an upgrade. That's our business.
100%, Kyle. I fully agree with that statement. It's a very funny one with customers as well, and in customer calls when we talk about longevity or, oh yeah, but how long will you guys be selling this module or this processor? And I give them the answer that you usually give me, and it's as long as you're buying, we're selling. These products can live 20 years, 25 years. Really, we know of use cases that still are there with probably i.MX 6 and 6 ULLs and Vibrids.
All of it.
It's really driven by the market at this point. It is driven by customers. That longevity is really important. And you mentioned a very good point. It's not about only the hardware longevity. It is about software still being there. Because if we cannot boot a Linux or the latest Linux kernel on these processors, they're not going to do much for you.
For sure. And NXP, we put our money where our mouth is from longevity. And that's what all this slide is about with Linux. You can go to nxp.com and we publicly, not behind a login wall, we publicly state what our longevity roadmap is. We commit it corporately. So you can go up and see the processors and we state it that this is going to be guaranteed for 10 to 15 years. And we're one of the only companies out there, and that's a major advantage when you're sitting across the table from somebody saying, hey, are you still going to be around? And I'm like, oh, yeah. And now that I've gotten a little bit older, I'm now saying this chip's going to be selling after I retire, right? I mean, it's going to be around for a while. And that also isn't just for customers that Toradex and I are going to, this is also for Toradex. So NXP has to be able to convince Toradex and say, look, we're in it for the long term because they need to know we're going to be around. And we worked together for many, many years. And I think we've proven that we are. And so that they can then say, we're going to be around as long as you have business to their customers.
So, what kind of Yocto layers are we talking about here?
All of it, right? To us, it's really about there is a lot of enablement that comes directly from NXP. They're the silicon owners. They are the experts around making an i.MX processor do what it's supposed to do and expose the features it's supposed to expose to a module or to an application. Where we try to come in for customers is taking away a lot of the complexity around building an OS image. That complexity comes from trying to take already the existing Yocto layers and Yocto recipes from NXP and then adding more layers around that. From there, we create our Toradex BSP. You might know it as Toradex NXP. Over that, we can add security layers. We have Toradex security, where you can really do all the secure boot, TPM, Opti, encryption, all of that stuff. PQC, that will come later on with post-quantum cryptography. It's really a layer, a Yocto layer that you would use to add security and harden your devices. Most of it comes as well from known work from NXP and known work from the community.
Right. And I would, for anybody listening that has ever done a repo sync with a flaky mirror that takes them 6 hours to get all the dang packages on, and you end up having to put some of them down that you just download yourself because you can't afford the repo sync, and then spend 2 hours on your machine to actually build and parse the recipes on Yocto, and then spend 4 hours building the thing only to find out you missed a package. Those people know what I'm talking about and how frustrating that can be. And that's really a summary of what Toradex does for this. They make it easy. They actually make the build of a Yocto image easy, which is usually antithetical to what Yocto actually is sometimes.
That's true. And we do take out a lot of the struggle. Let's say we keep it on our side, and it's value. Reducing struggle is creating value in the end. And then on top of that, we add the OS, right? So with Torizon OS, you are able as a customer to take all of this and to add a Docker engine for containers, to run your own containers. You add OS3 for doing diff updates rather than downloading full images, and then doing device monitoring and all of that in the cloud. So that's the whole software offering from Toradex. It all comes in Yocto layers because that's how it should be. That's how, in order to serve thousands of heterogeneous applications and customers on a very generic platform, Yocto today is the way to go. And the other point I'd like to also emphasize here, in order for us to be able to maintain a module in the field with NXP as well, maintaining a SOC in the field for 10, 15, 20 years, approaching this with an upstream first philosophy is crucial. This is how you make sure that your device stays supported for the long run. And it's not only supported by individuals, but by a full community of people. I know i.MX 6 now is on the upstream kernel. It just runs on its own. It has a life of its own today. It has, how do you say, Kyle? It's like when your child graduates and goes to college.
Yes, the 6 is off into college, man. Yeah, no longer have to worry about it.
Exactly. And that's how we really see software development at Toradex. You've seen probably that we're not the biggest, right? By far not, but we're one of the biggest contributors to the Linux upstream and to a lot of the support packages on the upstream kernel. We do a lot of Freescale SOC support, which was basically the NXP things we have today, the NXPS SOCs, and then other driver patches, etc. It's all there. We really benefit from this. It does not come without some drawbacks or some time loss, I would say, because it takes time to upstream something and without the effort, but it pays off in the long run. And that is what we look at. We don't look at the immediate effect only. There's a decade of field work coming up. The more we can work upstream and push things to the mainline kernel, the better off we are later in the future.
Yeah, y'all definitely embody the upstream first philosophy.
So, software reliability is also a crucial design concern to keep in mind, right?
It is a major part of what makes our software better because it's not magic. It does feel like magic, but in the end, it's not magic. It's about systematically having a philosophy and then systematically applying it every single time you release. And that philosophy is every single time we have a nightly release on our whole software stack that includes all the BSPs for all of our products, we run about 800 different tests every night that are in a climatized chamber, our climate controlled chamber in the back of the office. We test all those interfaces on our boards and their carrier boards. And what makes this a lot stronger than I think a lot of the competition is that we expose all of this publicly. So you can check every single night what the new release or the new nightly release is incorporating, is fixing, or is also breaking. But you can see all of that live on our developer website. I don't think there's anybody else that does that today.
All right, so we've talked a lot about CRA recently here on Chalk Talk, but we should also talk about the Cyber Resilience Act in terms of these types of applications, right?
Yeah, I've had a number of different, both with Toradex and with others on CRA, and it certainly is quite an important topic. And if your listeners to the Chalk Talk here don't hear anything except for CRA, you're a step ahead. So the CRA is a Cyber Resilience Act. It applies to digital products that are sold in the EU market. In essence, it is mandating a number of different cybersecurity requirements with a conformity assessment that the customer actually goes through themselves, but also has a declaration of what they can and can't do. And it includes post-market obligations. So why is it here in the first place? Well, that little blurb on the slide there says it all. There was an EU policymaker that's famously quoted, "The industry had more than 20 years to fix this problem. Now we're stepping in." And so the point behind this is that as we become more connected, the challenge to make sure that we're also safe, and I'm not talking about safety so much as I'm talking about secure, and security means your device is safe. Somebody isn't able to jack it in or take it over or make it do something it's not supposed to do. These are real serious problems. And when you move to the point where even our lights in my conference room here that I'm presenting have a little chip inside of it that's using it to turn the thing on and off, and it actually has a fair amount of intelligence side of it, you can start seeing how broad this problem could become because there's compute capability being put everywhere. So CRA is basically a regulation that says we are going to do something about this and the customers are going to be involved. Now, here's the main takeaway. This has real teeth. It's real. And there are real significant penalties, probably the biggest one of which, if you don't do CRA and you just basically say, yeah, not for me, I'm not going to do it, very soon in the next couple of years, you quite literally could find yourself in a position that you're not able to sell into the entirety of the European Union. That's worthwhile to say again. You have to be compliant if you want to sell a single gadget into the EU, and that regulation is going to start coming down in the next couple of years. NXP has been a part, we were a plank owner on developing what CRA became. So helping to get some industry intelligence into the regulation movement to put this in place. We've been at it from the beginning, and you can go to nxp.com and look at a lot of documentation that we've done for, say, our i.MX 9.3 processors. These are the processors that are available today on Mouser.com. But the thing is that this actually is kind of retroactive. So one of the things that we're spending a lot of time on is making sure that we are able to comprehend what needs to be in place for all of the NXP products, because we absolutely have a very large business in the European Union and we want it to continue.
So, talk to me about the different network level protections and vulnerabilities found in devices that you're seeing these days.
Well, and this is what I was saying, is that hackers go after the weakest link. It's straight out of the military, right? You don't go attack a system head on at its strongest point. You find the littlest, weakest link you can get your hands on and go. And so something as simple as not changing or putting out a default password for a printer. That's one of my best examples. It's like the modern day idea that nobody knew how to program a VCR back in my day, on the clock and stuff, right? But it was all the same default setting. And I'm not trying to pick on the printers, but back to my point that the printers that are coming out have full application processors on them. These are very, very capable processors that are doing all your documents on the printer and scanning and allows you to interface to it. Heck, they're going to put AI into it. So you can talk to the printer and say, hey, please go scan this and do something, put it into an AI RAG model. The point is if that has a default password on it, 12345, I'm just making that up. This is one of the things CRA is trying to get, because if you're a hacker and you can get into that printer and take over that processor and it's connected to the network, boom, you now have an island to start your attack. And it's not some dinky little, tiny little thing that can barely run any code. These are full Linux machines, quite possibly with AI MPUs inside of them, and they make a wonderful place to go do it. So I'll get off the printers, and I think everybody understands is that these really weak links that exist, this is what CRA is trying to get these vulnerabilities out. So this is inappropriate device configuration, saying, we're just going to put some default values in there. I really beat the dead horse on the access control mechanism, so that default password. But this also includes software bugs in COM stacks, application stacks that can be assaulted, and unpatched vulnerabilities. A vulnerability comes out, there becomes an obligation to do something about it or declare where you're at. So when we talk about this, it's about being proactive about what your device can and cannot do.
So, walk me through what all CRA covers and what it doesn't specifically address.
Right, is a great question. So, first of all, that was a bit of a fire hose for me. If you're completely new to CRA and don't even know what that acronym means, it's going to be okay. You're not too late yet, but you need to get started. And CRA, it may sound really onerous, right? Well, what CRA covers, and there's a whole discussion points that you can have both with Toradex, with NXP, with Mouser about what this means. But what the CRA covers is defining what your product can do from a configuration, authentication, how it's accessed, and what kind of data protection you have inside of it, plus a plan to fix vulnerabilities and do product updates over time so that as new attack vectors come in, you're able to do something about that. Now, what it doesn't do is say, this is the level of security you must have, or the functional requirements that you must put in place to make this happen, or how you're going to go about it. It's very much so about reporting proactively what your device can and can't do. Now, if somebody's building a point of sale terminal that is meant to be outdoors, completely accessible to public, and has access to a major bank's infrastructure, that's going to have a higher level of vulnerability, access to the product requirements than, say, a smart alarm clock. right? There absolutely in the spec is the ability to differentiate between what the intent of the device is. And there's a lot of leeway here to say, this is how I'm going to go about doing these vulnerabilities. And I think this is smart by the CRA authors, is that they're not trying to dictate a specific solution because they want innovation. They want people to continue to innovate in the way that works best for them. So this may seem a little onerous if you're new to this, maybe a little scary, but just get involved. It's really not that bad. And there's a really good chance that you already have done most of the work already.
All right, so Mohamed, Toradex has an innovative open source industrial grade software platform called Torizon, right? So give me some details about this platform and how it can help secure devices against a variety of different attacks.
Yeah, indeed, Amelia. So, as Kyle was mentioning before, there is a lot of work around how to secure a device and what needs to be secured. So, what we do here at Toradex, and especially with Torizon OS, is to provide you a set of recipes and a set of code and features that will allow to create a secure device in the end. It obviously always depends on your end application, what level you need to get to, and what you need to prove to market regulators. What we try to do here with our offering on the hardware side, the OS, the application, and the cloud side is to accompany you throughout all of these small cases or all of these small building blocks that you will build incrementally that will help you to prove your case towards CRA compliance. We start off with hardware, right? Encryption, root of trust, chain of trust. That's how you make sure that the data on your device or on your eMMC cannot be re-exposed by unsoldering it. People think it's a very hard attack. It takes 150 euros and 30 minutes to get all of your image out in plain text from an eMMC by a random amateur. It's a real problem. And I go back to the printer because that's the example I have in mind as well. All the documents that you've recently scanned are going to live on that eMMC for a bit of time. So you can imagine how sensitive that data becomes if it's not encrypted. If you are looking at a medical device, you want to make sure 100% that Linux image that is booting and that file system that goes above that is actually the file system that the manufacturer and the user have flashed into it. That's secure boot. That happens from the hardware. That happens from NXP IP with all the, EdgeLock and all the secure elements that we have there. That's what we help you enable in the end. It's work. You can enable it yourself. But what we do is we do that in an open source, in an open way, with all the recipes that are there for you. On top of that, you start with the OS itself, where again, encryption and Docker helps a lot with privileges and with, let's say, sandboxing. And then one of the last things I want to talk about here around the cloud and around managing your fleet, because with CRA, you need to talk about or to expose everything you do around vulnerabilities, but it also means you need to update your system. And in order to update your system, you need a secure update mechanism. You need a fail-safe update mechanism, and that's what we provide. It's a mix between what we do on the cloud and what we do on the OS side.
Well, but Mohammed, didn't you find that there was some reporter, I think in Germany, that wanted to see how hard it was to pop an embedded C off of a board? And do you remember what the answer was?
It took them 30 minutes and 100 and something euros.
Yeah.
They popped everything off.
For a non-technical or hardware-oriented reporter.
Exactly.
And you can extend that to any storage device. I mean, it can happen that quickly.
Yeah, exactly. The example you gave as well, Kyle, before, I would say it's such a small example, but it has so much implications. The random root password.
Mm-hmm.
We don't allow you to do that on Torizon OS, for example. You boot for the first time, you have to put in a password, and it has to be a very good one. And that's what probably some people don't also see. There's a lot of tiny details that you have to look at. It's not about having a console boot and then you can do, you name dash A, and then, oh my God, I have a Linux booting on my device, and that's it. And now I can go to production because my Yocto recipe works. If your root password is default or non-existent, yeah, within 3 days in the field, you are done.
They will find it.
So yeah, we try our best as well to help our customers and all our users on Torizon OS to not just make their application development easy through containerization and through a fully managed OS that is based on Yocto, but also through all these security mechanisms and security features that we've implemented. Part of it is software features, the others are software enablement of hardware features that we get directly from the NXP portfolio with EdgeLock, with the secure enclave, and all of that. That is really important. It cannot be good if your chain of trust doesn't start with a very secure element in the applications processor.
Kyle, walk me through the different security solutions that NXP offers.
Well, it forms the basis for everything that Mohamed just said for people. And Toradex is a great example where they take this infrastructure and add significant value on top of it and ease of use and everything you just said. Some of the things that we focus on, there's actually 4 areas to this. There's secure enclave. So this is a secure enclave within our chip that is there to deal with secrets and authentication. That coupled with secure enclave would allow you to then make sure that you have authenticated this software image that's coming into the chip. And it's very hardened. There's different levels to it in terms of its ability to do more and more stuff for the customer. And at the end of the day, it's kind of a gatekeeper for software coming into that. And if you see something that doesn't match what it's supposed to match, it will halt the chip. And we also have solutions for people. I mentioned that whole cash machine that's out in the public, that's access to a full bank, blah, blah, blah. Some of these solutions actually need to go a step above that. And we have our EdgeLock discrete secure elements. Now, these are full common criteria for compliant devices, which means basically that just means there's a whole bunch of things we have to do to make sure they're manufactured and nobody has gotten into the manufacturing line to muck around with something and put a back door in and stuff like that. Now, we always obviously protect for that, but the spec that it hits is so much higher because it is protecting secrets that have such an outsized impact. So you can absolutely add this accelerator to any of our chips as an external component to get that extra leg up. We also do EdgeLock's accelerators. So, a lot of this is about authentication, but some of it is going to be around, hey, I need to have an encrypted Ethernet TCP/IP port that I'm talking to somebody else. It needs to be fully encrypted. And I need to be able to do IPsec. Basically, I'm encrypting packets. So as we go up the ladder of performance within i.MX, we put in ever greater levels of security acceleration. And some of our newer processors are going to get up to line rate, in the gigabit, 10 gigabit kind of range. And then finally, there's EdgeLock to go. So EdgeLock to go is a key management platform. That's what its role in life is. And in essence, what it means is you can help control your life cycle on what keys go into our chips by using that solution. What's really, really great about this and what I love about working with Toradex on this is that Toradex's solution, as Mohamed had just talked about, will be able to use all or some of these services depending on what they need to do for their customer base and take advantage of that because it's all about getting stability at the base. If your base is not stable, your building will topple. So we try very hard to make sure that we're ready for this. And this goes on to things like post-quantum cryptography, PQC. And if listeners are not familiar with that, post-quantum cryptography is basically we've come up with a way, the industry's come up with a way to encrypt data that will flummox or confuse or cause a problem for some future quantum computer who can plain text our current algorithms in months. By using post-quantum cryptography today, your embedded MMC that's been encrypted is actually encrypted in a way that will take decades to centuries for any future quantum computer that tries to crack it. And that's a big movement underway. And NXP was actually a part of the PQC spec. In fact, we actually wrote one of the encryption standards. So security is very much a way of life at NXP. That's usually the very first requirement we start writing down whenever we come up with a new processor. We say, what are the security requirements?
So EdgeLock can protect applications throughout their lifetime, right?
Yeah, the whole life cycle. That's the great thing about working with partners like Toradex because they're able to take these basic capabilities and expand them fleet wide, thousands of customers, that sort of thing. But basically, there's really four key points to it is the customer's ability to securely manufacture. So you need to have everything from firmware to the installation of your keys. Some people don't realize how powerful an attack vector, a debug port can be. So the ability to turn that on because your developers need to debug things and see what's going on and permanently turn it off or turn it off in such a way that you have to have the secret key to turn it back on so that a hacker or somebody that steals the device or even buys it can't just happily go in and get a backdoor directly in the processor. And that includes remote key installs. So securely manufacturing has many facets. Data integrity and protection, secure connection, and detect, respond, and recover are all aspects of once you've manufactured the device. Being able to secure your boot, have infrastructure to enable secure over-the-air upgrades, isolation of different software, isolation of memory. One of the things we've been doing with the 9 series is putting in full DRAM encryption so that we plug that hole that has been in existence for quite some time where you can do all the security you want, but once it gets into DDR, it's very likely plain text. And there are very well-known techniques to pop the memory into a reader that basically sits in between the processor and the memory, and they'll just happily read all of your DDR. So we have a number of customers moving to, yeah, we're just going to encrypt the whole thing. That is another example of that. And then also detect, respond, and recover. So one of the attacks on a boot would be we're going to just keep booting this with a whole bunch of different attempts to try to screw the device up. Well, we can measure how long it takes to boot, and we can have customers say, you know, if it takes longer than X, whatever X is, this is an attack and we need to shut down or potentially brick the part, depending on how sensitive things are. That also includes tamper detection, you know, the active and passive tamper detectors. So if you try to cut a PCB or you try to cut a trace, it will cut those lines and they're very hard to defeat. You can even have a tamper detect on the enclosure. So if you open that enclosure, the chip knows somebody unauthorized is trying to get in there. And you can brick the part if you want to, depending on how secret things are. So this is just a laundry list of capabilities that we provide as a baseline. Again, the base needs to be secure so that partners like Toradex and our customers are able to take that to the next level.
So we've talked a lot about why security matters, but let's talk more about how we can build enhanced security on Toradex SoMs.
So on Toradex SoMs, we took the approach of layering security in as like a layer inside your whole cake when you're building or baking an image. The core of it is reutilizing NXP layers from their hardware layers and from standard Yocto tooling, Opti, TPM tools, TMCrypt, all of that. Basically, what we do is we take all our portfolio and put it into a single Yocto layer, MetaToradex security, that you can then reuse into your own recipes. And we have examples on how you use it into the recipe. So going back to everything that Kyle was saying before, what we do here is enable you when building your system to have secure boot, to actually be able to sign your images, your firmware, the Linux image itself, to actually be able to sign it with a secure computer or what is called HSM, so that you can put those keys in a very secure location so that they don't get stolen. They're generated randomly, and then we help, or we basically, our stack is compatible with that kind of signing so that you can make sure that the image that boots is the image you actually want to boot. And it's the thing that you've created and tried to flash on the device. Of course, encryption with all the cryptographic algorithms, whether it's the vanilla AES or RSA or future PQC. If the NXP SoC supports it, we have it. That's exactly what we're trying to do here. That whole layer exists because we've seen the demand as well from customers and from people all around. It's a very opinionated field as well around how you do things and what is the correct way to do things or not. Putting it out as a layer that is independent from the rest allows also a lot more flexibility for customers to add more things as well to their application, to build their own OS image, to build with something else than Yocto. When you have that isolation, it also helps us to update this at a certain pace that may not be the same pace as usual releases. And then we can add all our Toradex SoMs one by one whenever they get released as well. So we've had a lot of discussions on what is the best way to do this. I think the best way to do this is to provide it, not do it in a certain way. That's how it should go. I don't think anyone else has a security layer like us at this point.
Kyle, NXP has a robust portfolio within the i.MX family, right?
Yes, we absolutely do. And, I'm going to turn the mic over to Mohamed to go through all the different portfolio products. But, one of the things we've been doing with Toradex, with i.MX, we've been working together for years, decades. Toradex in particular, when we came out with our i.MX 9.5 processor, we chose to work with them directly at the very beginning because we needed a little help to provide boards out to our customer base because the processor had a very, very strong ramp rate, a lot of interested companies, and we simply couldn't support the number of customers we had. So we engaged with them very early on to build a i.MX 9.5 Toradex board alongside our normal EVKs that we build. And it was a great relationship, and it allowed us to get exposed to and expose more customers to 9.5 than we could have done on our own. But Mike, over to you, Mohamed, on the overall portfolio here.
The 9.5 story is still one of the best experiences as well, where we were able to show to everybody that when you put Toradex and NXP together, we got a really good evaluation kit. We got a lot of customers that are NXP customers. They don't need to be Toradex customers. What we've done is we've served a community that needed i.MX 95 chips early on, and they were able to develop. One of the things that is really funny is that this EVK right now is on the upstream kernel. So actually, people who were evaluating it got in touch with us to help them a bit with all the upstreaming effort. And we actually upstreamed that machine onto the kernel. It's on the mainline kernel.
Right.
With the upstream kernel and an upstream BSP. You won't get all the features, right? Because there's a lot on the downstream side, but hopefully at some point when 9.5 reaches the maturity on the upstream kernel, those boards will live again. I really love that they will never become paperweight. That is amazing.
Right.
And it was a lot of help also from NXP to really get there. The support, just phenomenal. To go back to your question, Amelia, on portfolio, I think NXP have a very diverse and long-standing portfolio of applications processors on i.MX. We started with i.MX 6 and then added here, and you can see it also on the slide, we've started to add them up piece by piece. So we have i.MX 6, i.MX 7, 8X, 8M Plus, and 8M Mini, as well as now the family growing through the i.MX 9. So 91, 93, 95. And as Kyle hinted on earlier in the session today, there is more coming around the 9.5 and the 9.3, something in between, or some things in between. We have our eye on it as well, and we want to leverage pin compatibility and the scalability from NXP, and then add to that the pin-to-pin compatibility and scalability you have on Toradex families. As you can see, a Verdant module can scale up or down between 8M Mini, 8M Plus, and i.MX 95, and that goes for all our families or our module families.
Well, I think that's all I have time for today. Thank you so much for joining me, Mohamed.
Thank you, Amelia. It was a pleasure.
And thank you for joining me, Kyle.
That was a delight. I really enjoyed this session. It was great.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, you can head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EEJournal.